In this try it exercise, we're combining everything that we've learned in this section so far involving rational exponents. We're also going to use some previous properties that we should already know involving exponents. I've written those properties down to the right of each problem that we're going to be utilizing. Uh, with part A, it's simply that when we have the same base and different exponents and we're multiplying, we add the exponents. So a to the m times a to the n equals a to the m plus n. And then if we have a to the m divided by a to the n, we subtract the exponents, a to the m minus n. So we could simplify this first by making all of the exponents positive and going from there, but we don't need to because of these properties. We can do that in the process of adding and subtracting. Just have to be careful not to lose a negative symbol when we're doing that adding and subtracting. So in the numerator, we have m to the 2/3 times m to the negative 1/3. So that would be m to the 2/3 plus negative 1/3. Well, that's 2/3 minus 1/3. And then we're subtracting the exponents that is in the, we're subtracting the exponent in the denominator. So it would be minus negative 5/3. Well, minus negative is plus a positive, so that's plus 5/3. Now we put all those together. We have 2/3 minus 1/3 is 1/3, plus 5/3 is 6/3. So this ends up being m to the 6/3, but 6/3 is just 6 divided by 3. That's 2. So this equals m squared. Now in the second problem, we're going to use this property that a times b to the 1/2 equals a to the 1/2 times b to the 1/2. In other words, when what we have in parentheses, we could further extend this to a times b over c all to the 1/2 equals a to the 1/2 times b to the 1/2 divided by c to the 1/2. The point is that when all that is involved inside the parentheses is multiplication and or division, we can distribute that exponent. Now remember, this doesn't apply when we have addition or subtraction. In other words, a plus b to the 1/2 is not a to the 1/2 plus b to the 1/2. We can't distribute the exponent when we have addition and subtraction, but we can when it's just multiplication and division. So 25 to the 1/2, and then we're going to keep the m's together. So this is going to be m to the 1/6 over m to the 2/3. That's still going to be taken to the power of 1/2. And then last but not least, n to the 11/6 divided by n to the negative 1/6. And again, that's still taken to the power of 1/2 as well. Well, 25 to the 1/2, that's just the square root of 25. So that's simply going to be 5. Now let's simplify what's in the parentheses here. Remember, a to the m over a to the n equals a to the m minus n. So m to the 1/6 over m to the 2/3 equals m to the 1/6 minus 2/3. Well, that is simply 1/6 minus 2/3. That's 1/6 minus 4/6. And 1/6 minus 4/6 is just negative 3/6. That's still being taken to the power of 1/2. And then n to the 11/6 minus negative 1/6. So that's plus 1/6. So 11 plus 1, that ends up being 12/6. That's still to the power of 1/2. So we still have our 5 out front. Negative 3/6, that's negative 1/2. So negative 1/2, we're taking an exponent to an exponent. So negative 1/2 times 1/2 is negative 1/4. And then n to the 12/6, well, 12 divided by 6 is 2. So this is n squared to the 1/2. So 2 times 1/2 is just 1. So this is n. Now we still have to get rid of this negative exponent. So we move it to the denominator and make it positive. So this is 5n left on top and m to the 1/4 in the denominator. So this entire big expression up here simplifies to simply 5n over m to the 1/4. Now we could be told that we need to rationalize the denominator because technically this is a fourth root. So we would multiply top and bottom by m to the 3/4 over m to the 3/4, and that equals 5 times the 4th root of m cubed times n all over m. But for purposes right now, this is an acceptable answer. 5n over m to the 1/4.